Okay, so distributed control system is called also DCS, which is computerized control of all the control loops that are in that system. Okay, mechanical specialist engineer, them being who? Heat transfer, rotating equipment, vessels. They provide estimates of exchanger shell counts at the beginning of the job. If there is a service to cool or heat some fluid, they will say, okay, this can be done in one shell, or one shell will not be enough. There have to be 2 or 3 shells sometimes if it's a big process flow and big exchange, heat exchange. So they will provide this estimate, provides equipment summary with utility requirements. Now that example that I've used, big compressor with cooling seal oil, lube oil, there might be cooling water required to come from outside of this package. Am I too quiet? Okay, I shall speak up. Okay, so I better get some water. So these packages might require utilities such as cooling water or fuel gas or instrument air or plant air, and these utility requirements are taken care of, in other words, made known to process. Vendor data as it comes in, we talked about that before. Now the piping engineer, how does piping engineer collaborate on the P&IDs? Issues piping class specifications that the P&ID engineers can use on their P&IDs. Remember, because of the pressure, temperature, corrosion, erosion, and all that, certain piping classes have to be provided. And these definitions are done by piping. Input into utility distribution P&IDs, that's a minor point. Equipment layout. Remember the plot plan? Plot plan shows how the equipment is laid out. Vendor data as it comes in. And the tie-in list. What are tie-ins? In every process plant that has to be revamped, in other words, we go in and start doing things to it, an operating process plant. We are adding equipment, for example, that needs lines to be connected to the existing lines. Anytime that connection is made, it's called a tie-in.
I was just going to say that on every project I've been in,
yeah, that is a misuse of process engineering. But you're right. Yeah, and that's one of the consequences of what the type of work that we were given in the last 10 years. If you go, for example, to Asia and talk to their contractors, or to Houston, some of the Houston engineering contractors, they will not worry about process doing tie-in lists. It's always done by piping, and it is in our procedures to be done by piping. Okay. Yes, Oscar?
The existing equipment or pipeline?
Yeah. If we are connecting new to an existing system, that point is a tie-in point. So tie-in list is a list of these tie-in points. They are listed by location, size, and process characteristics of the fluid that goes in. And then piping prepares the tie-in list. Process engineers, if necessary, will add process data to it, or just verify that the process data has been properly interpreted by piping. And then piping will provide tie-in packages for every tie-in that there is in the plant. Piping will provide tie-in package describing what needs to be done, whether it's got to be done on the run or when the plant is shut down, before the shutdown, after the shutdown. Some tie-ins require doing it while the plant is running, and there are special precautions to be taken. So all of this is done by piping. I'm going to skip a lot of this. If you want to ask questions about this, I'm more than happy to talk about it. If not, we're done with this part. Anybody wants to ask any clarifications about these two slides? Okay. If not, we're going to go to that handout that you picked up today. Now, P&ID development process is something similar to an opera. Opera has certain stages. The first act, the second act, the third act, and you have all these actors. And every opera follows a script. We want to be most efficient. Therefore, we have to follow the same script, or the most efficient script possible for the P&ID development. I have written down the stages. These would be like the acts in the opera. First, for the process flow diagrams, there are only 3 of them. For P&IDs, there is a whole bunch more. And you can understand, since process flow diagrams only express process steps, whereas the P&IDs show the system, that the P&ID development is much harder. It requires much more collaboration than the PFDs. So we're going to go through that development process of PFDs first in a nutshell, and then P&IDs. Now, at one time I worked on a real big chart, which you show here, which I put here. You can, during the break during the break, you can come up and see. This is like the, what do you call this thing for opera, when all the notes are put in? The score, yeah, that's the score for PFD and P&ID development. And that part is actually covering the process development, or the process design, as we call it, and the system design, and also detail design. When you go there, there is a word construction. I want to warn you, construction is not a part of the construction phase. It's a part of the detailed design, or the detailed design phase. So we're going to be talking about work processes, the script, PFDs, PNIDs, and both times we're going to be talking about work processes. Every work process has its input, the work process itself, and the output. Could be more inputs, could be more things in the work process, could be more outputs, just more than one. And we go through iterations in process flow diagrams because we have better data as we keep working. In PNIDs, going over the same stuff again. This is one thing that I keep mentioning every time we talk about iterations. Sometimes we do lose heart because we have to go over the same stuff. So I keep encouraging everybody, in this business you must never lose heart no matter how many changes are thrown at you. If you can do that, you're going to make a lot of money. Literally. No, it sounds funny, but it is true. If you can persevere and be dedicated and have the same stamina, whether you have the first change or you have the seventh change you have to work on, you're going to be successful. And it's hard. So soft boundaries we did talk about before. There are boundaries between process steps. There are boundaries between those issues. There is a very good definition of that in our standard company procedure covering P&IDs. I think the number is 111. Not the one that was mostly given to process engineers from here. There is one that was developed by Houston, which is much better. So I don't have it up at my fingertips, I think, but if you are interested, I can point you in the right direction. Okay, so we go step by step, inputs, work processes on those inputs, and then products. And here is the first part of one of your charts that you have there. When preparing the process flow diagram, we take raw material specifications, product specifications. Remember, those were developed during the product design. We're now in process design. Intermediate specifications, if there are any, and various standards. And we do some process planning. That's the first step. The second step, the yellow is the first step, it's already done. Second step is preparing the scoping process flow diagram. So we have certain inputs into that, which you can see there in your chart. And as a result, we produce, if we do process design, as I said, most of the time we don't. So most of the time we get somewhere here or maybe here and then try, and then when we verify it, we go back and we go into approval stage. So if we did it from scratch, process engineers will prepare the preliminary or scoping process flow diagrams. And once that is done, the next iteration is preparing the approval process flow diagrams. Approval process flow diagrams meaning we have now incorporated everything that there is to know about this process. All the process steps are now described properly, and we certify that we have read the client data properly and interpreted everything properly so that we can issue those process flow diagrams for approval to the client. That's the second act of the process flow diagram opera. Now completed. This is mostly done by process, not much input from anybody else. Then the client comes back and said, well, you didn't interpret this or that properly, and in the meantime we changed our mind. Now they shouldn't say that because we charge them more money for it. But if they do, remember, we don't lose heart. We just keep going. Those changes get incorporated. There will be some in-house comments. In-house comments might come from the leads of the other disciplines who are now beginning to think about what they will have to do. They're not really doing anything, but they might have some comments. The management and so on will comment on it. If there are any consultants associated with process design, they will be called in and their comments will be incorporated. And so now we have PFDs for design. That's the last act for process engineers to complete on the process design. That's the second tier in that pyramid that I told you about before. Those who have been here last Wednesday, you still remember the pyramid with Mr. and Mrs. Consumer on top? Yeah? No? Yeah? Okay. So now we are going through P&IDs, and again it'll be the same deal, step-by-step inputs, work processes, and products of those work steps. When I was with one of the companies before, we prepared that thing on the right hand, and we tried very hard to harmonize not only process, this describes process, which P&IDs are a major portion of it, but we did same kind of diagram for piping, for instrumentation, electrical, civil, structural, I'm not sure about machinery, but all the disciplines who spend most of the time and most money on the project have been covered by these. And we have discovered that some of the outputs that people have been producing were not connected, because we made connections. Every time there is an input from another department, there would be connection to their chart, and they were all numbered. So everything was interconnected, except a few of those activities that process department would produce something, and we found out that there is no connection from that product to another department. Or another department was producing something, and nobody was connected to that on the receiving end. So we asked them, I forgot, some summaries were being produced, and so we asked them, what do you guys do? This was in the time everything was done on paper. What do you guys do with it? And so some said, well, we'll look at it, see what it is, put it on this pile. And others would say, well, we'll look at it, we'll put it into this pile, in the round file, in other words. So they got rid of it. So in doing that, we found that there were some products that nobody wanted, but they were nice to have. So we got rid of those. We improved the work process, in other words. Question? No? Okay. I don't see much action today. So now P&IDs go through these development steps. First, develop the project plan. This is done by the leads in process, and they produce the design criteria for process, manpower plan, execution walk-down plan, execution plan, walk-down plan, and general specifications. We will talk about these a little bit later. So what is P&ID walk-down? That'll be the next step. If you remember, we talked about the PSM legislation, and the PSM legislation legislated about 10 or 15 years ago that all P&IDs in chemical production plants, including refineries, which we are intimately interested in, have to be up to date. So there was a big push. In the early 90s, we had all these young engineers going out and updating P&IDs all over the country, in all chemical plants, refineries. They were really busy. And they produced P&IDs that were as built or up to date up to that point. Now, in the meantime, there was no new legislation, so some of those refineries, most of them, all of them, have not updated their P&IDs. So when we get a new project, we take those P&IDs, and if you go and look at the plant, P&IDs no longer fit. So the first step is to select the P&IDs that need to be prepared, or updated, rather, and produce an issue of P&IDs that is an accurate representation of what's out there in the plant. That's the first issue, called as-is P&IDs. Some people call it as-built, but as-built only happens at the end of our project, not at the beginning. We haven't built anything. Somebody else did. So those are as-is. That's an as-is P&ID issue. And then the process engineers will produce the next issue, which is preliminary P&IDs, which they'll do some hydraulics, produce preliminary pump head sheets, and preliminary machinery data sheets. Remember, that's the first cut. It's not quite clear as whether they are going to be firm. So it's always called preliminary. And the preliminary issue of the P&IDs is produced and reviewed in-house. I put this in parentheses, in-house review, because sometimes we don't even do that. Sometimes we do more of these. If the definition is not that firm, we can have more than one preliminary in-house review P&ID. Sometime, on the other hand, we have clients participating in the reviews of those preliminary P&IDs, and it's still called in-house review. In-house should mean just us. Not that we would have anything to hide, but it's best to have it prepared before we go to the client. Okay. Any questions on this? Yes, sir?
Essentially, this flow chart is taken from all the responsibilities we covered earlier.
Right. Yeah. We are taking it from different angles. See, there was an angle, what P&IDs mean. Then there was an angle, what kind of P&IDs we do. Another angle was who is responsible for what. And now the final angle is the succession of the work. And after that, I'll shut up, but it'll be maybe 7 o'clock by the time it happens. Okay. Any other questions? Okay, so the next stage, when we have in-house review comments, I should have gone back one more slide here. We put those and other other documents that are included, and we issue now officially the P&IDs should have everything included that we ever known about the requirements of the client. We have put in all kinds of hydraulic information. All the lines have been sized with real size, well, real numbers on them, real sizes. All the equipment is sized. Everything, every basic type of information is on the P&ID. So now we can say, okay, now we are ready to go to the world, and we issue those P&IDs for approval. For approval, meaning going to the client and telling them, this is what we have ready for you, would you like it? And so they can come back with some comments, again, misinterpretation or some changes of mind and so on. They come back, and then in the meantime, though, there will be other things that the process department is working on, which is covered by this step when they develop more data sheets, remaining data sheets, now that they have a little bit of time because the client is looking at the approval issue of P&IDs. So these data sheets get prepared, and then we go to the next issue. But before we go to the next issue, we review the P&IDs for safety issues. Safety issues. Relief valve analyses get done. Insulation is firmed up. And those kinds of issues are reviewed in-house, mostly under the direction of the process engineer responsible for the P&IDs. And we also incorporate the client comments from the approval issue. Okay. So the next issue is now the familiar word already. We go out for HAZOP. So P&IDs get issued again, and the HAZOP issue is the one that undergoes the HAZOP review. Anybody has any questions on those little things that I'm just skipping? Don't be afraid to ask. So when the HAZOP report comes back, we will be issuing for design finally. But before then, there will be other things that process department will be taking care of while this HAZOP is being done. Other people are going to be working on all the other issues, and they will issue pump head sheets, for example. This does not cover all the products. This just covers most of the main products that are produced in these steps. So by then, we'll have all the data sheets. All the data sheets are out, meaning the process engineer has issued all the data sheets to the proper specialists for adding mechanical data so that they can be given to whom to go out to vendors? Who goes out with the data sheets to vendors?
Can you repeat that?
Who goes out with the data sheets to vendors? Procurement, yeah. That's a good answer. Gee, I need to walk like this because either I'm losing my voice or it's not strong enough. Okay, well, whatever. So we have gone to the vendors, and now the vendors, as a part of our orchestra now, they are working on looking at the data sheets, looking at the parameters that we're asking them to satisfy for the equipment. So they are working on their bids or offers. They are offering some products to us that will satisfy the process requirements and mechanical requirements. And so in the meantime, the HAZOP comments get incorporated into the PNIDs. And finally, we will have the PNIDs issued for design. Sometimes we call them design PNIDs. All that means that they are at the design stage. So PNIDs are now issued for design. And if you remember about the word starting with an F, what happens when the PNIDs are issued for design? What's that point called?